What I'm showing you is going to come in much handier when you're into doing difficult integrals next year. So the point I'm trying to make is you could do all of the questions I'm going to show you from the divide by the derivative of the inside. That'll get you through all these. But later, you're going to get more complicated ones in which you're going to have to know what's called the substitution rule. So I want to teach it to you, again, not because I think that it's going to change your life this year, but next year, when you see this stuff, at least it's like, oh yeah, okay, we did this, and then it makes your life easier next year. Okay, so we're just actually going to just skip this page, and we're going to go to the substitution rule. Gotta love Thursdays. Okay, so if we have the integral, of f of g of x, meaning there is a function inside times g prime of x dx. You guys are going to love this. It's the integral of fu du. See, the math nerds weren't thinking when they came up with this one. That's what happens when you're so isolated. Okay? Now this may not make any sense right now until we get some examples. So you got your composite function, you got the derivative, the inside, right? So we're going to take something that you probably think is pretty easy the way you know it right now. We're going to make it really complicated so you'll be able to do harder ones next year. Okay? So here's the method that you kind of need to do for these. So first of all, you want to recognize the proper form. Okay, so what does that mean? It says, is the composite function being multiplied by the derivative of the inside function? Now, so when you did the derivative, you know that that's going to come out when you do the chain rule. So we've got to always counter that. Okay? And again, this will make more sense when we're doing examples. So we want to define u of x. In other words, let u be the inside. You know how we've always been dividing by the derivative of the inside? You know that inside I'm talking about. And then differentiate this function, and then isolate the term. Then we will sub u of x and d of x. If done properly, all the x terms will cancel. Everything will be in terms of u. Then we're going to integrate u. And then we're going to substitute u for g of x. So if you're doing a definite integral, which we'll work on tomorrow, we're just going to do indefinites today, and you wish to remain with the new function, then you must change the limits of the integral. Okay, so if you have from f of x, g of x times g prime of x dx, and that's going from a to b, our new function, which is our famous f of u du, we're going to do u of a to u of b. Okay, so we're going to see that more tomorrow. And again, this stuff probably looks just totally like gibberish right now. So let's do 4 examples. Oh, 6. Okay. Now, we've done all these before. Nothing big. But we're going to teach you how to use the substitution rule. Okay, now, we always want to define our inside. So we're going to, on the side here, we let u equal x cubed minus 2. So u is going to be our inside. So then we do the derivative of this. We'll do du over dx equals, now this is weird, right, because you're doing derivatives now, 3x squared now, we're going to want to substitute this into here. But there is no du over dx. But there is a dx. So if I switch these two, I will get du over 3x squared equals dx. Now, all I'm going to be putting is my substitution. So I am going to take this and this and get it into here. So this would be the integral of u to the negative 3 times 3x squared times du over 3x squared. So I haven't done any integrals yet. I just substituted x cubed minus 2 becomes my u, and dx is du over 3x squared. Okay, then do any cancellation you can. So I've got my 3 and my x squared. So then I am left with u to the negative 3 du. Okay, now let's do the integral. This would be u to the negative 2 over negative 2 plus c, because du over du is 1, right? Now you just want to finish with getting back, or getting rid of the u. What is u? It's x cubed minus 2. So this would be negative 1/2 x cubed minus 2 to the negative 2 plus c. Now I'm just going to do this one with you to show you comparable to what we were doing before. Before, we were just taking the integral, right, which would have been, so this is the before when we were just dividing by, so this would have been negative 1/2 x cubed minus 2 to the negative 2 times 3x squared, and then I said divide by the derivative of the inside, which was 3x squared. Oh yeah, plus c. Right? Cancel is negative 1/2 x cubed minus 2 to the negative 2 plus c. So if I was you right now, I'd be going, the old way was a lot shorter, a lot less work, and made sense. Okay? These are all very simple antiderivatives, very simple integrals. When you get into the tougher ones, you're going to see where substitution will help you. Am I going to get into the tougher ones this year? No. Okay? So, do you always have the option to do both? Yes. But do I want you to see it so you're a little bit familiar with it, so when you see it next year, you're like, oh yeah, that's substitution rule, okay? So, I'm going to spend the rest of today and tomorrow just doing the substitution rule. You can keep both on your radar so you know how to do both, and then you can do it on the test, whichever way you want. But okay, so let's start doing these together. What would be my u for number 2? x squared minus 5 du over dx would equal 2x. Therefore, du over 2x equals dx. Okay, so then we do u to the 4 times 2x times du over 2x. See, right there, you're seeing a little part of the old way, right? We're still dividing by the derivative. Okay, this cancels. Okay, then I have u to the 4 du, and I'm going to not rewrite it again, right? We can see because everything cancels, so now I'm just going to do the integral would be 1/5. We could even put in our u right now. Just x squared minus 5 to the 5 plus c. Actually, just for, we should have had 1/5 u to the 5 plus c, right? And then plug it in. Yep. Always when it's indefinite. If it doesn't give me 0 to 8 or whatever, then I can't find a value. Therefore, I will put plus c. Okay. Okay, these will go faster once we just start getting into the, okay, so I got sine. Now this one, always make sure that you see it as sine x squared cos x. Okay, so what would u be? What would u be? Sine x du over dx equals cos x. What a coincidence. Du over cos x equals dx. Cos x dx. Or to the left, my integral sign. That s. Okay, that's my left. That u. See how I did a u there, and I did a u there? You would think you would have. So it's like 3 times later you ask what my u's look like? Yes. It's the machine. I usually have perfect penmanship if it weren't for this thing. Okay. So this would be of u squared cos x du over dx. Okay, so then I'll do the integral, which would be, oh, sorry, d over cos x. So my cos x's cancel. 1/3 u to the 3 plus c, and u is, so that's 1/3 sine x cubed plus c. Okay, so I got cosecant 3x, cotan 3x, x dx. So what would u be? Yeah, the 3x squared. It's the inside of the composite function. Du over dx would equal 6x. Therefore, du over dx, or d over 6x equals dx. So I need to find the integral of cosecant u cotan u x du over 6x. Okay, so this one starts to get where, oops, why did I keep doing that? Over 6x. Okay, so you got to be a little bit careful. The last 3, everything canceled. This one, only this one will cancel. So really, I'm going to rewrite this one. We have 1/6 cosecant u cotan u du integral. Okay, what is the integral of cosecant u cotan u? So that's negative 1/6 cosecant, cosecant u plus c. And then we'll finish off by getting u back in there, cosecant 3x squared plus c. Okay. We needed more of that? No? Okay, next one. What's u? Let's get through these two. 3x squared plus 7. So du over dx equals 6x. So du over 6x equals dx. So we'll do the integral of u to the 10 times 6x. Oh, this one's a pretty easy one. Okay. Times du over 6x. Cancel, cancel. Now we'll do the integral, which is 1/11 u to the 11 plus c. And then I'll put in u, 1 over 11. U is 3x squared plus 7 to the 11 plus c. Okay, last example of the day. What's u? 3x squared plus 7 du over dx. Holy, loving this 3x thing. Okay, is 6x. Okay, so we're doing the integral of u to the 10 x. Oops, I forgot to do this part. Du over 6x equals dx times du over 6x. X's cancel. And I'm doing the integral of 1/6 u to the 10 du. Okay, so I'm going to go 1/6 u to the 11 over 11 plus c, which is 1 over 66 u to the 11 plus c. Plug in u now, 1 over 66. U is 3x squared plus 7 to 11 plus c. Okay, so I understand that we know how to do it by just dividing by the integral or derivative, but I do want you to practice this because that'll help you with next year, right? And there's your hopefully not homework.